I don't know what's this happening. Then it's fine. For those, how many students? 14, right? I will ignore those who have not attended. Why it's not recorded? So it's recorded now?
Yes.
Okay. Okay, no matter. Thank you for your mention.
Dr. Bank, just maybe a quick question before.
Yes.
So when we say MVT and MPT, so MVT is at a constant volume and MPT at a constant pressure?
Exactly.
Okay.
Yeah. Okay. They have some reduced form. For your project, each of you will get from here you will see mean and Jones potential. We only have two parameters. One is sigma, one is epsilon. Right. This parameter is energy, related to energy. This is related to the length. So each of you will have a different assignments for the potential. You have a different potentials, right? To complete. Okay, wait 1 second. To complete the project, you need to go the tutorials. DL Monte tutorials. You will have the tutorials 1, 2, 3. You need to. We do a little bit last time for the MVT, Yin and Jones. Right? You need to finish this. You also need to go MPT. Right? You need to do MPT. Also, you need to finish RDF, tutorial 3, RDF, radial distribution function. So you will gain the sense what's the radial distribution function. Right? This one is used to determine the structure. If it's solid, I mean, if it's amorphous, it will have a very different shape to the crystals. And you need to finish the exercise, how to do RDF calculations, how to plot it. Right? What is sense? You need to finish the tutorials 1, 2, 3. Okay. A little bit more. Yes. Let's see. Let's go to the PPT again. So you will have different parameters. So each of you will have different tasks.
Dr. Bank?
Yes.
You say so the MVT, Leonard-Jones fluid tutorial, RDF, and what's the third one?
The first tutorial is MVT, right?
Yes.
The second tutorial is NPT, right?
NPT. Oh,
and
okay.
the third one is RDF, radial distribution function. If
okay.
let me record this page. Let's see. Tutorial 1 MVT, tutorial 2 MPT, and the tutorial 3 RDF. Okay. From this, you can do you can understand and do the project. Also, come here. So let's see. So you will see here is an example. Once you do Monte Carlo simulations, here we have the units of 10 billion steps. Right. This still do very quick. All right. Last time you shows 10,000 Monte Carlo simulation. You just take 0.5 seconds. Right. So you do millions. It's a little bit longer, but you can still do it. So the energy we plotted last time, the energy, right? The energy per atom. So you divide the total energy with your number of atoms. Then you plot the energy as verse time. You will see verse time. You will find it will fluctuate. It fluctuates around average. So you take the average. You will have a value. This the energy. You need to record it. This one temperature. If it goes another temperature, you may have a phase change from crystal to liquid. You will see the transition temperature is around 93 K, right? So you will see difference in energy. Right? This is something you need to record. And if you plot the energy, what you got from last step, from energy, you have an average, plot with the temperature, right, at a different temperature. You will see it will change a little bit, but around the phase change, you have a critical temperature. Here around 94, right? You have a jump, you have a discontinuity. So you will, from here, you can tell me, you can tell right in the report, the critical temperature is 93, right? 93 K. So this is something you need to report. That's your results. Also, how you tell the geometry. We showed last time how to see the movie. So you will see if the temperature goes 75 K, it's more or less like a vibration around the equilibrium. It's vibration. If it's close to melting temperature, the vibration is large. If above melting temperature, you will find no crystal anymore. So from here, you can judge. For example, if you have, if you see your system is like this, so you will do what? You need to reduce the temperature, right? You will to reduce the temperature. So you will back and forth, and find what's the good temperature it is. So you need, eventually, you need to have a curve, the energy versus your temperature, right? So this for the critical temperature. Sometimes you need to plot the pressure, then you will see the critical pressure. Sometimes you need to plot the density, right? Once you have one parameter, you have others, because these are the same output in the run. Right? So we also need the radial distribution function. You will see if it's crystal, like temperature 74, red dash line, 74, you have something, radial distribution function, it touch almost 0. Another one, 92, a little bit low, but it's different from other two. If it goes to liquid, it will have a very different.
Doctor.
Yeah.
What is the y-axis?
Y-axis is a radial distribution function. Y-axis is radial distribution function. If we go to the tutorial, it has the definition. What's this y-axis? Radial distribution function, all right? So this radial distribution function, you will find through this you can judge the change of structure. That's how you tell. If I go from very beginning, the 3 tasks. So use radial distribution function to determine the structure. If it's solid, it's ordered, it's crystal or amorphous structure. So you need radial distribution function to do that. Also, if we do NPT, all right, if we do NPT, each time you have equilibrium, then you have a different lattice constants. You will find the lattice constants changed with temperature. It's changed with temperature. So you will have also a discontinuity in lattice constants.
Dr. Bay.
Yeah.
So if we go at a higher temperature where it's completely a liquid phase, we don't have a lattice anymore. So what does happen to the points or the dots? Does it go like lattice constant goes to infinity or? No. This lattice constant actually is divided. I mean, the lattice constant, you have the same simulation box, right? We already say it's already 4 by 4 by 4 or whatever. So we just take the average. We not go to infinity. Yeah. Your simulation box is still there. Okay. Another is the size effect, right? As I mentioned, we need to study the size effect. So you will see if we have the size, here we define is a number of lattice constants. So we have unit cell. That's, for example, is if FCC. Then we repeat it to make a supercell. How many cells we repeat in one direction? Because we will repeat in 3 directions, right? So if we set 4, that means 4 by 4 by 4, X, Y, Z, repeated. As I mentioned the last time, we use periodic boundary condition, right? 4 by 4 by 4. So you have 4. Then if we increase the size, so each dimension we repeat 5 times, 5 by 5 by 5. Then we go 6, go 8, go 10. You will find the parameter critical temperature changes, right? This is called a size effect. You need to study that. That's crucial sense. And next, I will tell you how to build up the model for config. So do you have questions so far? So you already know what the project we are, right? Project 1, let's go shortly. Monte Carlo simulation of melting. We will study, use radial distribution function to determine the structure. We will find, you need to report to me with your parameters, what's the transition temperature, transition density, and study the size effect. It's due October 15th, 10 p.m. sharp time, all right? So you will learn 5 items: final size effect, determine the critical temperature density, get the information from the visualization. You need to differentiate the structure of crystalline and amorphous, understand the equilibrium. Right? We use Lennard-Jones potential. We have 2 parameters, etc. We have each of you. We have a different parameters. I will send you. I don't know how to achieve this, but I will send you email individually. So what's what you have, what's the parameter you will get, right? I will do it randomly. So, what you need to do, you need to calculate the, you need to print out and calculate, you will see the energy, the total energy versus the steps, right? Monte Carlo simulations, steps I mentioned last time. So you will do your, will do the record. You need to record this, the average energy here, and plot with the temperature. At each temperature, you have a different value, value of energy. Then you will see there's show me the change, the phase, phase change, right? This critical temperature. For in this case is 94. For other case is maybe 300. So you need to find out. You will see the geometry. If your temperature is too high, you'll see this melts. If it's too low, you will see it's a crystal, right? It's a vibration around. So you will know how to approach the critical ones. You go to the middle, right? If you see this, you increase the temperature left side. And if you're get a melting one like this amorphous, you know it's too high. You go back to a lower value. Then you know eventually you will find the critical temperature, right? Later you need to judge the radial distribution function. You plot it out and see is a crystal or amorphous. And then you need to plot the lattice constants versus temperature, or density versus the temperature. You find the critical density. You need to study the size effect, right? Yeah, just a very quick of this. Go back again of this project. I will post this project on the Blackboard soon. Do you have questions so far?
Do we plot the graphs using Python?
Yes, you plot this with Python. We can do easily with that. Last time I showed you, I can show it again. Just 3 lines. We easily plot that. Yeah, you can do that. Yeah, easily. Also, I will have the tutorial session in each week in the Thursday, as we said last time. Each Thursday, I will give you sessions. So if you have any questions, we can I can show you how to do that. Also, if you have questions, ask through the Telegram, so we can all help each other. We can discuss. All of you, please discuss each other. Do not hold, all right? Be open to others, but do not copy, right? You cannot copy because I will assign you different parameters. Your mileage will be different, but the method is the same, right? You follow exactly the same procedure, but you have a different parameter. You have same formula, yeah. Questions so far? I saw someone is. Yeah. If not, then we will go ahead. I will show you. I know the most difficult part is the very beginning. How do you build your model? How to build your model? So I will give you a demo. How we do that? How we do that? I will not. It's not the one I'd like to show. So actually, I will give you tutorials how to build up your configuration file, config file, right? You still remember we have 3
input files. One is config, and other is force field, is field. The third one is control. Yeah, so let's do the basic one, config. How to build up your config file. So we will use a software called Atom SK. The Atom SK is in this this link, but we will do that later. So Atom SK is very powerful and a small tool that help you to build up the model. Right? All of you, please follow me to do that. Right? I have opened a web browser, right? Like Google. Let's Google Atom SK. As easy as that, right? Atom SK. Let's say download, for example. So let's say download Atom SK. Right? Every one of you, please follow me. You go to this web page. You also remember the trick, right? You can split your window. You can split your window. So you can saw what I'm doing and repeat in your text in your computer, all right? So you'll see I have go to the downloads, and you know what? Please download this version, Linux. The Linux. This one for the others you need to install. This one you do not. You just need to unzip. Yeah, that's an easy one. You right click, right? Say copy, the copy link address. You copy the link address. Yeah, if you have not do that, I can share to the chatting session. If you cannot do this.
Doctor.
Yeah.
Should we use 32 bits or 64 bits?
That's depending on your system. In general, we use 64, right? We use 64. You can download it, all right?
So I can download Linux AMD 64.
Yes, download the AMD 64, AMD 64, that version. AMD 64, yeah. Let me show you. I give you a demo how to do that in the command line. All right, let's see. This something I just opened my. Let me from the very beginning. Just give you a clear demo. All right, let's see. Say let me open just from the very beginning, everyone. Yeah. So I just started my Ubuntu. Right? I will go to my working directory. Last time we already built. You will have your own working directory. Well, it's MC, well, Del Monte, whatever. So this time, for example, I'd like to generate something configs. Or maybe just do something like a Atom SK, all right, Atom SK. Just whatever you like, but keep that in mind, right? You make mkdir, just comment to make a directory called Atom SK. Right? So what do? You need to wget. So you get from website, right?
Doctor.
Yep.
I don't have Del Monte.
Why? I think everyone have it since last quite a few. So what's your issue right now? Which one?
Yeah, you know, from yesterday. Yesterday I just downloaded Ubuntu and I tried from the start of the day. I tried to download everything, but I haven't got Del Monte yet.
Do you have Ubuntu first? Do you have Ubuntu?
Yes, I yesterday I finished downloading Ubuntu with you.
Okay, yesterday you have Ubuntu. Then you have you just go ahead, follow the tutorials. We have videos for how to get Del Monte, right?
Okay.
Well, yeah, follow the. I will not go all the process again just for yourself. We have the records. Please
Okay.
go to our videos. Yeah.
Okay.
Yeah, for this one, we now do nothing about the Del Monte, but today we are working on the atom SK. So in the atom SK, if you do not have Del Monte, you can still work on the atom SK today with me. All right, just follow this step. So here we can download it directly. Previously, you already right-click, you already saved the link, right? And here in the terminal, you can just put the comments. wget. You read my my screen, right? wget, and this one is just copied, and already please find this link in the chatting zone, right? You will get this wget. I just do that for you right now. You will see just in 0.7 seconds. You will download this, right? Everyone, please follow. What do you have? Your ls. You will see what's inside your folder. You will find you already downloaded, and you need to unzip it. You do what? tar gxpvf, right? So we are type AT, then you type tab. It will automatically have it, right? You type AT, then tab. It will automatically have. Then you just enter. Now you will unzip everything. See? Please follow. So otherwise you will get lost again.
Can you please go back to the command for unzipping the file?
Go back to, well, so you need to download.
No, after the downloading, I mean the zipping the file, unzipping the file.
Okay, unzip, right? Unzip is this one, this comment. I will copy this comment to the chatting zone, so you can copy easily. Okay, I know this sometimes maybe not easy to. Okay, here I type it. So TAR, always unzip. You always TAR ZXPVF. Z means unzip. Z is GZ format. All right. X is extract. Right. And the other parameters, please find by your own. Yeah. So you can do that. You follow me, right?
Yes.
Yes, great. For those who have not attended the class, if someone asks such questions, please help them. All right. Once you know it, once you help them, you do repeat this process. You will learn it. Otherwise, you do this once and ignore it. You may forget it in 2 or 3 days. You totally forgot. All right. So please try your best to practice. You will see the programming. And this computational stuff is a skill. Sometimes, if you understand it, you still need a lot of practice, right? Let's see. If you have unzipped it, you will see what? You will see this. You have a folder. You have a folder called atom sk, right? CD. Then we change the directory to atom sk. You use the tab. It will automatically fill. You go to this directory, right? Then you do the ls again. You do ls. You list it. You will see you have the files there. If you are with me, you will see there are install sh, uninstall sh, etc. But no worry, you already have the file atom sk, right? So what do? You just copy atom sk to your bin directory, all right? You just need to do this. Copy atom sk to your bin directory. You may already know what the bin means, right? It's binary, it's executable. I will copy this to the chatting zone so you can follow. So each time, next time, everything you have executable, you just do that. Copy atom sk to your bin directory, right? As simple as that. All right. Are you following me?
Sir, I'm not having the chat zone.
You do not have what?
The chat zone.
You do not have chat zone. Then look at my my screen, right? I will do the properties. I will change the screen size again to 40 to make you better view. Can you see better?
Yes.
So you will see the copy atom sk. Atom sk is already here. You will see atom sk and copy to your bin directory. You need this. This means the home directory. So every time you use a CD, that's a home directory, right? And we have a bin directory there. If you do not, you can always make a bin there. If you do not have bin directory, you can use this. You can use make dir bin, right? You can always do that. Then you make a copy. So everything should be fine so far, but you need to check what's atom sk, which atom sk. If everything goes well, you will see atom sk is in my bin directory already, in my binary already, right? So if you type the comments, which atom sk, you will find it. You will find it will show automatically. Please let me know you have done this.
Yes, I done.
Great, great. Now you have the atom sk ready. All right, you have atom sk ready. Now we have the program. We can use it, right? For here, for example, I make a directory. You see, I come cd ... Just means I go one level. I go to the upper level, right? One step upper. Right? So you will see I'm come to the atom sk this folder. What I'm doing, I want to make directory for config. I want to make a directory for configs, for example. For example, all right? You can do whatever. You can do C or whatever, as easy as you can, right? Once you make this directory, please enter it. Please enter it. So now I enter it. Okay, this is a trick you guys need to learn. This very simple one. You CD, you have this, you know, these two characters, right? You have this one and I have a $1. Then that means what's the last item? What's the last item? You easily go to your previous, to the directory you're just created. You make a directory. You will see this one is empty. If I type ls, it's empty. Nothing shows, right? You're with me, right? Anyone? Everyone?
Yes, with you.
Okay, great. So now we want to make the configuration, configure files using atom sk. So it's simple as this, atom sk, right? You'll follow me, right? Then you have two minus, all right? That's dash. Say your creates. We need create. Then we need to say creates FCC, for example, right? Say we want to FCC aluminum. We use the elements. We need the elements. We use aluminum, for example. Okay. If I remember clearly, we need something like a 4, like a 4. We need a number. That is constant, and aluminum. Then we also need a dash, right? Here is a single dash, right? Called duplicates, all right? Duplicates, right? So we say 4 by 4 by 4, for example, right? Then we say config. Say config. It will generate the file in 0.014 seconds. Everyone with me?
Yes.
Yes.
Okay, anyway, I will copy this to the chatting zone for those who have chatting zone. All right, let me save a little bit. Okay. So you will do it later, right? So what I do, you will see, okay, that's VI. If you do not, the first time, please do this. Sudo apt install vim. If you do not have VI, you do something like this, right? No matter you have it or not, you can do this. If you're already installed, then you say it will not install. If you are not, it will install it immediately. This is called a VI. This is something very useful. But later you will find your own way. They have thousands of ways to do the editing. Someone use less, someone use nano, someone use there's many programs that can do. But the VIM is a simple one, right? So we do install VI for those who are the first have the Ubuntu system, all right? The Linux system, you need to install that. Now let's do ls. You list what is the file in your directory. You will see what? You only have one file called config. So why is config? Because in our previous comment, right, in our terminal, we say this, we create the atoms, it's saved in config. So we have one file called config, right? Now, I'm trying to open the config for you. Open the config. right? We open the config. Please with me, right? Now in your config file, you will see what? You will see the first line. That's the title. It's just for comments, so do not have any meaning. So you know this one tell you we have a FCC aluminum oriented in X direction 111 100, right? Y direction 010, Z direction 001. This orthogonal. Then we know this is 3 parameters, but what most important thing is here 0 means we just have positions. We do not have velocity. We do not have the force. We only have position, right? And the last one tell you how many atoms in this config file. So how many atoms? How many atoms? 264. Why? Why is 264? Let's come back to you. You can open the Python, do the calculating, because each FCC cell it will have four atoms. Each unit cell of FCC have 4 atoms. And how many cells in our simulation box? We have what? We have 4 by 4 by 4, right? So we have 4 cube.
Dr. Beck, sorry,
yeah.
but how did you get back to the list? Because I only have the columns with the values right now.
Okay, I'm too fast. Sorry for me. Let's go back. All right. Now we go. You are still in VI, right? In this, right?
Yeah.
I do too fast. Yeah. You do column. Please type the column. Show me. Please notice the something I highlight here. Column. You're in the bottom left. In the bottom left, in my mouse, give you this column, right? Give the column. I type Q. Q means quit, right? I type column Q. Then we exit. We quit it. You see? Follow me.
Okay. Yeah.
Okay. I'm happy, everyone. We are the expert, but you guys just the newborn, all right? You're just newborn. You just have hands on this new things, right? You're already quit config. Then you can easily go to Python anytime, right? You can use Python. I always use Python as a calculator. Sorry, it's my bad habit, but it's very convenient. So you use Python, and then you do what? You can use this as a calculator. So as I explained, in each unit cell, FCC unit cell, you have 4 atoms. Now we repeat the 4. That's where comes the 4? Because we duplicate 4 by 4 by 4, right? This is 4 cubic. So this 4 cube. So you do what? How to cube? How to do the power? You do multiply, right? You have a double multiply here. Then you have put a 3 there. Then we have the number 256. Just tell you how this 56 comes from. How this 56 comes from, because it's a double check. Why is 254, right? Do not get lost, right? So let's come back to config this file again, right? You can use VI or VIM. Sometimes it's equal, all right? They are equal. So you can easily to control your keyboard. You're back and forth. You see, well, what I do. But here there's a very, very important comment for this. Please keep in mind, look at the bottom left, what I'm typing, all right? I type column, one column. Just always ask you do the comments in the VI editor. So you follow me, you do this. You do column.
Sorry to interrupt again, Dr. Bing, but it seems like I'm stuck in Python. How do I quit it so I continue of writing the command in Ubuntu?
Okay. Sorry, I'm too quick. Yeah, because I think
bear with us a little bit. We will
yeah,
get fast.
yeah. I need to slow down. Thank you for your reminder. Because yeah, if we go Python and finish the calculation, for example, you need to Control D. You see Control D. It will automatically. It's working. So please see my camera. You know the control, right? You know the control, right? Control key in your keyboard, right? And you have the D, the letter, the D, Control D. Then you have quit the Python, right?
Okay, yes, it works.
You guys, you tell me, it looks like you guys never playing the games, right? If you play games, you can use keyboard or use mouse. I tell you, use keyboard is much faster, right? You can always have shortcut. It's easy. For the mouse, you need to use your eyes. Use your keyboard. You do not use your eyes. You just do whatever in your figure. Right. Now, I think everyone know how to quit the Python. Just Control D, right? Just Control D, easy. Right? Now you have. Let's go back to the config again. You're with me, right, everyone?
Yes.
Okay, good. Okay, good. Now we come back to the config, and no matter where you are typing column. You're typing column. If you're typing column, that means you want to do the operation. You give the comments. So what you are doing? You comment. Okay. You have got column. Then you have S. You have a slash. Right. Yeah. Follow me. AL. What's AL? Because aluminum we already said. But now I want to replace it with LJ, Leonard Jones atom. I do not want to be aluminum. We use it as a Leonard Jones atom, LJ atom. Then we type G at the end. All right, for your good. Let me increase the size again. Sorry. Maybe. I should do the properties. Then go to 60, right? I go to maybe go 80, 60 first. Let's go 80, right? Make everyone happy, right? Let's go 80. Okay, it cannot be. It's 72. That's the limit. All right, 72 is maximum. All right. So you're with me, right? So you have column S slash aluminum LJ and G. G means global. I want to substitute globally, right? Then you enter. Once you enter, you will see everything changed to LJ. Sorry, I missed the one important thing. We should have a percentage. We have percentage, all the percentage. S, A, L, J, A, L, L, J, G. This global, right? This changed everything. So your file right now will read like this. Everything replaced AL with LJ. You guys already have LJ here, right? You follow me, right? All the aluminum, all AL replaced with LJ.
Yes, they were replaced.
Great, great. You can do this. Column, you do write and quit, right? You do write and quit. You have this at the end. Wait 1 second. Let me test it first. All right. So no, so you do this. After doing your write and quit. So column W Q. W means write. You write it first, then quit, right?
Writing it, you mean like so it saves it?
Yes, your write means save. All right, let's save it. Yeah. Sometimes you do not want to save, then you just quit without save. Something do this, right? Without write, without save. So now I'm quit. Now I'm outside. All right. So if you do ls, you will have configure. If you want to double check, let's go to the file again. Right. Double check everything is saved. It's still LJ. Everyone with me. I think all of you with me, right?
Yes.
Okay, good, good. So what I need to do? Actually, there's too many things on my screen. I use, sorry, not clean, clear. I use clear, right? So everything, you will see we have only one file called config in the folder, right? So what I need to do, we need to move, rename it. Actually, it's rename, move config to what? To, actually this size is too large, it's giving me trouble. Let's go to 60. Right, you move config and you use config dot fcc dot 256, right? Maybe say 4 by 4 by 4. It's better for you to remember, right? Everyone with me? We have a config already, FCC 4 by 4 by 4, right? Now we will do the same for different sides. How to do that? We will do that. We will use, okay, use your arrow key, your arrow key. You go up, and go to your previous comments. If you can find it from the chatting zone, so you can find it also. Now we do 3 by 3, right? That's easy. You change the number from 4 to 4 to 4 by 4 by 4. Now you have 3, 3, 3. Now we repeat each time, each direction we have 3 times. Okay. It will complete 0.006 seconds. Now you use ls. you list it, so you have the file called config, right? So you go to vi config again, right? And you will see what's the number difference is 108. If you do the calculating, you will find 108 means is 4 times 3 cubic, right? 3 cubic is 27. You times 4, you have 108. So you come here. We also started with aluminum. Now please replace it with LJ. Right? Do that again. So now all of them substitute with LJ. Right? So we have a configuration of what? We have a configuration of 3 by 3 by 3. Then we need to save it as 3 by 3 by 3. Say FCC 3 by 3 by 3. Everyone with me, right? We are almost out of time. Then we can do 5 by 5 by 5. It's the same, all right? So we only change is the number. Now 5 by 5 by 5, right? It's just quickly you have it. So let's do the change to the config again, right? We just repeat such things. We percentage S AL LJ global. You get it, right? You will see for the 5 by 5 by 5, you have 500. Why? Because the 5 cubic is 125, and you times 4. That's 4 atoms per unit cell. So you have 500 atoms. Now you have 500 atoms. You save it and quit, and you move it. You save it as FCC 5 by 5 by 5. Right? You have FCC. That's 5 by 5 by 5. So you can repeat this. 6 by 6 by 6, 7 by 7 by 7, 8 by 8 by 8, 9 by 9 by 9, 10 by 10 by 10. So do this, repeat by yourself, right? You can have the configure file ready. Yeah, I know you guys have a Lex class very soon. So I think that's the class today. You guys are safe to leave, but if you have questions, I'd like to with you. Yeah, questions, please. If you have, follow me. So we have the configuration files. So eventually you will build up other parameters like field file, like control file. Please go through the tutorials carefully. Understand what the comments, what each line means. You need to use Google to find that means. All right. So you can do it by yourself to repeat the tutorials 1, 2, 3. As I mentioned, 1, 2, 3. And come back to finish your project, because everything is new to you. You will spend time for this. You'll see if there's something you just even copy me, you're easy get lost because these things are new to you, right? Yeah. So you need to come to this website to complete your 3 tutorials. Tutorial 1, MVT, tutorial 2, MPT, and tutorial 3, RDF. How you set up in your control file, how you do the simulations. Yep. So far today, we you know your tasks. We already have the project 1 announced. Please go ahead to finish the tutorials and do the project. Right? Here we have tons of questions. Please discuss in the Telegram and your WhatsApp. Everyone, please discuss and help each other. All of you are doing the same project, but different number, different parameters. Your results will be different, but the method is exactly the same. Hope all of you can learn from each other, right? If you are isolated, you feel very, very painful to do the study, especially like this course. Right? Do not be isolated. You need to discuss with the teammates, with our class. Then you can help each other, but eventually you need to write the report by yourself, all right? Questions? Otherwise, you guys are safe to leave. I will wait for those who have not followed me yet. I'd like to expect some questions from you that I can do my best, right?
Dr. Bing, just a quick question. If I want to modify already a config that I created, for example, I did 777 and then I changed 778, but I want to change it to 888. Like, how can I edit?
All right. For example, now you want to do 8 by 8 by 8. You should do from the very beginning. It cannot easy to modify because everything changes. For example, if you do 8 by 8 by 8 here, right?
Yeah.
Now you will have config immediately. Then you do this config, right? You do the config.
Yeah, I follow this, but I'm saying, like, if I created something with a wrong dimension, like 778, can I fix it or delete it?
You need to delete it. You need to delete it. Yeah. You will see everything, every number are different. If you do the comparison, you will find the number is different, right? Yeah. Actually, there's one thing I have not tell you, you guys. There are 2 kinds of configuration to make life easier. So we can have another easier one called a fraction coordinates. Currently, we are use Cartesian coordinates. Now we use fractional, right? So if you overwrite, yes, I will overwrite. So if we do this, you will find all the config is in fractional coordinates, right? So you have 2 kinds of coordinates. Actually, the fractional is preferred. Fractional is preferred. But currently, you guys should already be very familiar with atom SK, how to build up a crystal just in seconds. Right? How to generate config just seconds, not seconds, just 0.05 seconds, right?
Victor?
Yeah, questions so far?
When we will submit the first report?
The deadline, the sooner the better, right? But the deadline no late than October 15th. Let me come that again. So if I come that again, we go to the home. It's October 15th, 10 p.m. If I look at, if we look at the calendar, so you will see today is 13, is 30, right? 2 weeks later is Wednesday, 14, but a little bit more than that, 15th, the last day, 10 p.m. I hope you guys can finish that. Why I put to 15? Because the Thursday I also have a session. I have a session to help you guys. This is the last chance. If anything, I can help. Right? Keep that in mind. Yeah.
This recording will be on Teams, yes, Doctor?
What's your question, sorry, again?
This recording, will be on Teams, yeah?
Yes,
be...
this recorded. This recorded. Yeah. Please come back to the movie. So if you got missed anything, you can repeat it again and again. So you can learn. You will not get lost. All right.
Okay. Thank you.
Thank you very much. Thank you very much. You have class very soon, so you are safe to leave. Also, it's almost the end of the class. Yeah. Just wait a little bit for those who are shy to, to ask questions. So for those, you can save to leave. Save to leave. Yeah, you're safe to leave. I also download the, first I like to stop the recording. I will download the attendance. Okay. Stop.